Alright, so this is where we did reach last time. So we talk about the horizontal and the vertical component. H mean horizontal, V mean vertical, but sometimes they use I for the horizontal and J for the vertical component, right? Now, here, in this case, you have, say, a magnitude. Let me just erase this first. You have a magnitude of 7 and an angle of 30 degrees. Remember, sometimes we're going to use radians instead of degrees, right? Now, being the case, if you have this in a radians, what would be the angle in radians if it's 30 degrees? Now you remember, say, you have one entire revolution contain 2 pi radians because it's 2 pi r, alright? Circumference equal 2 pi r, 2 pi radians. And 2 pi radians, my gosh, RAD, alright. 2 pi radians is 360 degrees, so pi radians is 180 degrees. So 180 degree equal 2 pi radian. 180 degree equal 2, oh boy, 180 degree equal pi radian. Or could I just stick to the 360 degree equal 2 pi radian if you want to, no problem. 360 degree equal 2 pi radians. So 1 degree equal 2 pi over 360 radians. So 30 degrees, if you multiply both sides by 30, you're going to have 2 pi over 360 times 30 radians. So cancel down 3 into 3, 1, 3 into 36. It's 12, 2 into 2, 1, 2 into 12, 6. This will be pi over 6. So this is the same as pi over 6 radians, right? Same thing. But anyway, we're going to work with degrees. If you get pi over 6 radian, you must put your calculator in radian mode. If you get 30 degrees, you must put your calculator in degree mode. But anyway, suppose you say, find the horizontal and vertical components. I remember you saw 90 degrees, right? Horizontal and vertical components. So when I say H, that are the horizontal. Alright, so the vector 7 equal. Now, this would be this would be 30 degree times cos, right? Remember, is I plus J. So, in this case, I would have been what? Oh, make we write it like this. I would have been what? The V, like the V. So, I equals 7 sine 30. I. And J, no, I horizontal. My mistake. I would be what? Is horizontal. The magnitude at 7, we know the 7 already. 7 cos theta, but theta what? 30. So it's cos 30. And J is what? This J here, so. Would that be the vertical, which is 7 sine 30. Alright? So, here now. This 7 is really the magnitude, which is I plus J. Right? So you go I and you go J. So those would be the horizontal and the vertical components of the vector. Alright? Now, suppose you calculate out these. And you get 7 cos 30 and 7 sin 30. I could do the calculation and see what they come out to. Alright? So 7 cos 30 equal 6.062. Alright? 6.062. And then we have J now. Get to calculator again. Alright. So we have 7 times sine 30 equal 3.5. Alright, so we have 3.5. So this is 6.062 and this is 3.5. Now you remember your Pythagoras theorem? Suppose you consider this and say you have 6.062 and you have 3.5. This would have been what? Call this h. H squared equals 6.062 squared plus 3.5 squared equal what? We're going to calculate it. Suppose you draw for a calculator again and do it. What would happen? You have 6.062 squared plus 3.5 squared. 6.062 squared plus 3.5 squared equal. And then when we square root that now, square root equal, you get back with 7. So you see everything alright. Alright? So that is what you have. So you have the horizontal and the vertical components of the vector right there. Alright? Now, if you get a vector like this and they say find the horizontal and the vertical components, then you know what to do. Alright? But generally now, you might remember another way how you add two vectors. Because we're going to come to addition and subtraction of vector also multiplying. Right? Oh, this up here, so you know, it look funny. This should have been I and J. I and J, sine and cos, with the magnitude. Alright. So, in this case, we have a vector and we have the horizontal and the vertical components of the vector. Now, sometimes you get the horizontal and the vertical components of the vector, right? And you must do your thing and find the magnitude of the vector. You might have a case where they give you the vector v is equal to, and then you see them put some funny bracket like this and say 6.062 comma 3.5. Are the same thing as if them say v is equal to 6.062 I comma 3.5 j. Alright? Are the same thing. Now here, what I mean is that this 6.062 is the horizontal component, horizontal, comma, just want to make sure I spell it right, and the 3.5 is the vertical, right, T-I-C-A-L, vertical component, That is simply what it means. Alright? You have the horizontal component and the vertical component of the vector. So, if you get this 6.062 comma 3.5, and them say find the magnitude and angle of the vector, how you deal with it? What you can do is say, since the 6.062 can do as rough work, you go so and say 6.062, and you go so and say 3.5. Then you label the angle theta and the magnitude v with the two, the small v though, you know, with the two vertical line. And you know what to do after that. What you can do is use tan. Tan theta equal opposite 3.5 over adjacent 6.062. So theta equal tan inverse. Tan inverse of 3.5 over 6.062. Because you can clearly see it would have been the tan, right? If you have that as your right angle triangle, 3.5 over 6.062. So you say the tan inverse of open bracket 6.5 over 3.5. 3.5 over 6.062 close bracket equal, you get to 30 degrees, right? That's a 30. So theta equal tan inverse of that 3.5 over 6.062. So theta equal 30 degrees. By the way, let me draw this properly. This thing here. You would, even though I rough work, you know, if you draw so chaka like me draw it a while ago. So you have your 6.062 here and your 3.5 here, right? And then you say your V, all right, and the theta here. So as for the magnitude, you can use Pythagoras and say V squared equals 6.062 squared plus 3.5 squared equal what I give you now. When you do your calculation, you're going to say 6.062 squared plus 3.5 squared equal, and then you say square root equal, and you get 7. And you get 7 for that. So, given the horizontal and vertical component, you just draw your triangle and use trigonometry. Right, the trig ratio to find the angle, and Pythagoras we can use and find the magnitude. Alright. Suppose you have two vectors and you want to add them. Now, we're going to review some things that you're supposed to know already. You can use the triangle law, or you can use the parallelogram law as well. Right? If you use the triangle law and deal with this. The triangle law, as we say, is supposed to be like revision to you, because you're supposed to do that in some vector maths class before, and also in physics. Now, suppose you take this vector here. Let me draw a straight line. The vector A. Remember, you say A, magnitude of A is 7. And you have vector B. magnitude of 4. Alright, guess what? We'll just copy them now. So I draw them over and over like that. We just copy them. We make a copy of A and put it here so. And a copy of B and here so. Good. With the triangular, what you need to do is make the two vectors follow each other. Right? One book, remember, say they follow each other nose to tail. Follow each other around the triangle. But when you come so, you go back, then you have an opposition. Right? Now this opposition, when you remember, when you add two numbers together, the answer you call the sum. When it comes to vector, when you add two vectors together, the answer is called the, remember, the resultant. So you add them like this. Alright? That is how you would get them. Now, if you have them, you remember, say if you have them directly opposed, if it's 7 and 4, you say 7 minus 4 equals 3. If you have them directly like this, it's a 4, it's a 7, it's a 4 plus 7 equal 11. Alright? But we have them at an angle, so you can't treat them like that. Alright, so you have 4 and you have 7. By the way, what would be the angle? What would be the angle? Right? If you have this as a horizontal, this angle will be 45, right? And this here so, to the horizontal, remember, this angle at 30, so this angle would also be 30. So, if you have this horizontal, so this angle, 45 and 30, if you minus 180 from them, you can get it. Now remember, we just see what would happen if we use the triangle law and add them, right? So you must remember these kind of calculation with the trigonometry. 180, you take off 30 from it, and you take off 45 from it. You would get 105. So this would be 105 degrees. Alright? Remember, we just move this here and move this here. And you know, say, this dashed line up here is horizontal. Remember the magnitude, you know, it kind of look horizontal, but you know, horizontal. This dashed line up here is horizontal. So this is 30. This must be 32. Right? Like you are talking about vertically opposite angles. Alright? And this is 45. This down here, so this is Z angle. Yeah, they call it Z angle. If this is horizontal and this is 45, it's horizontal, this is also 45, corresponding angles, right? This and this. Alright, so this is inside here, so I want you to have 5 degrees. So, how will I deal with a case like this now? You know, this is 7 and this is 4. So, here now, you can use what they call the thing there. What they call it again? The cosine rule. And calculate the magnitude of this. As well as the angle. Right? So, if you say, this is the resultant, call it R. Alright, it should be small r. Resultant R. The magnitude of R equal. So r squared equals 7 squared plus 4 squared minus 2 times 7 times 4 cos 105. That would be equal to what? Alright, to get back we thing there, we calculate again and work it out. So what we have, clear the calculator. 7 square, well, you know, say 7 square of 49 plus 16, which is 4 squared, equal that minus 2 times 7 times 4 times the cosine of 105 equal what? 79.49. Call 79.5. And then you square root that and you get 8.9. 8.92. 8.92. Just about 8.92. Alright? No. The thing is, you want to know the angle of R as well. So if you find, say, this angle here, you say what is the angle from A? Now this is 8.92. That is the resultant, the horizontal. Oh my gosh, the magnitude, I mean, mixing up myself. In this case, you want that angle. So we can say that angle, we call it, remember this angle was here, we call it alpha. This is no longer horizontal. We draw the dashed line before to show horizontal. So call this theta, call it theta. So using the sine rule, 4 over sine theta equal 8.92 over sine 105. So sine theta would be, when you transpose, it will be 4 sine 105 over 8.92. Right? Oh, let me write this. R, the magnitude R equal. Alright. So, in this case, sine theta equal. And then, we're going to find the sine of that angle. So we have 4 times the sine of 105, my gosh, equal, all right, divided by 8.92 equal, and we get 0.433, 0.433, and then the sine inverse of 0.433, 25.67. All right, so it's 25.67 from 25.67 from A. So 25.67 from A. The vector A. All right. Now, it would have been the same thing if you use the parallelogram law. Remember what the parallelogram law says now? If I copy this shift it and put it here. Then I copy this, shift it and put it here. Then what you'd have is this same resultant would be, let me redo it again, would be this. All right, same thing, same calculation, same everything. But anyway, in the next video, we're going to redo this thing in another way. So I will see you then.